71, rewrite each of the following expressions without parentheses. And of course, the totally hilarious answer would just be to write, oh, x plus 2 x minus 5. I just wrote it with no parentheses. But of course that's crazy because it's not numerically the same, right? Regardless of what value of x you pick, they're not going to be rarely if ever equal. So, oh, look at that. That was interesting. So what I need to do instead is I need to think about the fact that what operation is happening here is the operation of multiplication. So I need to multiply the 2x plus 5 times x minus 5. At this point, I would venture to say that most of us do not require an area model to do a multiplication of a binomial times a binomial, but I like to show it anyway. So I've got an x and a 2, I've got an x and a negative 5. So these four products contribute to the product of this binomial. So I'm going to multiply x times x, and I get that's x squared. I'm also going to multiply x times 2, which is 2x. I'm also going to multiply the x times the negative 5, which is negative 5x. And I'm finally going to multiply the negative 5 times the 2, which is negative 10. So that's what the product of those, the multiplication we get when we multiply these two binomials. So if we were to write that out, right, there's an x squared that's part of the product, but then there's also this positive 5x and a negative 5x and a positive 2x. Well, if I've got negative 5x and I add 2x to it, that's going to be a negative 3x. So I have x squared minus 3x, and then I subtract 10. So this is what's meant by rewrite the expression without parentheses, right? I wrote it by multiplying out and finding the product of those binomials. Let's do b. B is interesting because it's got both an x and a y. So let's use an area model for this as well. So I see that I've got a y and then a 2x, right? So this edge, right, is like, oh, the length of this is y units long and then 2x units long. And again, this is a generic area model. I'm not trying to draw this to scale because I don't know how big x or y is anyways, and I'm not trying to model it with algebra tiles. That's just simply y and then plus 2x, and then this is a y and then plus 3x. So the four parts that go into this product are, one of them is a y squared, that's my y times y, and then I've got a y times a 2x, and I'm going to write that as 2xy, right? It's a 2 times an x times a y. And then I've got a y times a 3x, so I'm going to multiply that as 3xy. Get some xy's here. And then finally I've got a 2x times a 3x. 2 times 3 is 6, and x times x is x squared. So now we can look at all four of those parts, and we can see the product when we multiply those binomials is y squared plus a 3xy and a 2xy, which is plus 5xy, and then plus 6x squared. So there we go. This is the product that we get when we multiply y plus 2x and y plus 3x. I've totally run out of room, but that's okay. There's lots of room way over here off screen. So this next one, again, I'm going to sketch a little area model kind of off screen here. We're going to be multiplying a 3y and a negative 8, and we're going to multiply that by so 3y and a negative 8, and we're going to multiply that by a negative x and a y, a 3y and a minus 8, and we're going to multiply that by a negative x and plus y. I think I'm going to leave the last one and not do that, but let's finish this one. So what are our parts here? Well, this first box is interesting. I've got a 3y times a negative x. So I'm just going to write that as a negative 3, And then I usually list my variables in alphabetical order if there's more than one of them. So it's a negative 3 times xy. How about negative 8 times negative x? If I multiply those, I'm going to get a positive 8x. A negative 8 times a negative x is positive 8x. Then I've got a 3y times another y, which would be 3y squared. And then my final part is going to be, there's a negative 8 times a y, which is going to be a negative 8y. So I do not have like terms that I can combine here, right? So what I normally like to do is start with my powers and then write descending powers of the variable. So I might write this as 3y squared minus an 8y. And then I might write the plus 8x and then the minus 3xy. And I'm not actually committed to that order. And here's the thing, right? If you're adding 2 and 3, it doesn't matter if you add 3 plus 2 or 2 plus 3. And if you've got something like 3 minus 8, you can also write that as a negative 8 plus the 3. So you'll notice that when I commuted the 8 over, right, I brought the sign with it, so it's a negative 8 and a positive 3. So this is the product of these, of the binomials 3y minus 8 and negative x plus y. Last thing, it's here. I'll just show you this. Notice that I've got an x and times a minus 3y and an x plus a 3y. So pay close attention to that one. It's kind of fun. Look at the answer that you get there. Something maybe not amazing, but something mildly interesting happens.